Look closely at people around you. Two individuals, same age, same number of years lived, and yet their bodies tell completely different stories. One seems full of energy. Their skin, their movement, their recovery, everything feels slower, in a good way. The other feels worn down, tired more often, a body that seems to have aged faster than time itself. So here's the quiet question science began asking. Is aging really just about how many years pass, or is something deeper deciding how fast the body changes? For a long time, we believed aging was automatic. Each year ticks by and the body simply declines. But researchers started noticing something strange. Some bodies repair damage better. Some handle stress differently. Some seem to resist aging, not by staying young, but by aging more slowly. And the reason wasn't willpower. It wasn't luck. It was biology. Not a single youth gene, but a complex system inside the body that decides how fast aging unfolds. And once scientists began to understand this, aging stopped looking inevitable and started looking responsive. Most of us grow up with a simple idea of aging. Time passes, the body wears down, and there's nothing much we can do about it. Wrinkles appear, energy fades, recovery takes longer. We're told this is natural, that the body is like a machine that slowly breaks with use. And once that story settles in, aging starts to feel unavoidable. Not something that happens with us, but something that happens to us. So when we feel tired, stressed, or slower than before, we blame the calendar. Another year, another step closer to decline. But this belief hides something important. If aging were only about time, every body would change at the same pace. Yet they don't. Some bodies slow down early, others adapt, repair, and adjust. The idea that aging is identical for everyone is comforting in a strange way, because it removes responsibility. But it also removes possibility. And that's where science began to quietly disagree. Science eventually realized something important. The body doesn't age by the calendar alone. There's the age written on paper, the number of years since birth. And then there's another age, one you can't see, but the body feels. Biological age. It reflects how well the body is functioning, how efficiently cells repair damage, how the immune system responds, how the body handles stress. Two people can be 40 years old by the calendar, yet one may have a biological age closer to 30, while the other's body behaves as if it's much older. This difference isn't random. Biological age responds to life, sleep patterns, nutrition, long-term stress, environment, recovery. It changes slowly, quietly, often without us noticing. And this explains something many people feel but can't explain. Why some bodies bounce back, while others struggle to recover from the same challenges. Aging, it turns out, is not just time passing, it's time interacting with biology. When people hear the phrase age gene, it's easy to imagine something simple. A single gene that keeps you young, or one that makes you age faster. But biology doesn't work that way. There is no one gene that decides your age. Instead, scientists have identified many genes that influence how the body repairs itself, how it controls inflammation, and how it responds to stress. These genes are involved in maintenance, fixing damage, replacing worn-out cells, and keeping systems balanced. Some people are born with versions of these genes that work a little more efficiently, but that's only part of the story. These genes don't act alone, they don't run constantly, and they don't operate at full power all the time. They respond. They listen to signals from the body and the environment. Which means having good genes doesn't guarantee slower aging, and having average genes doesn't mean aging faster is unavoidable. The real question isn't which genes you have, it's how those genes are being used. This is where the idea of aging begins to shift. Genes aren't always fully on or completely off. They behave more like dimmer switches, turning up, turning down, responding to signals. This layer of control is called epigenetics. It doesn't change the DNA code itself. It changes how that code is read. And those instructions respond to daily life. Long-term stress can push certain genes into overdrive, especially those linked to inflammation. Lack of sleep can reduce the body's ability to repair cellular damage. Poor nutrition can slow down systems meant to protect and maintain cells. Over time, these signals add up. They quietly influence how fast tissues wear down, how efficiently cells renew themselves, and how resilient the body remains. But epigenetics isn't a one-way path. Supportive environments, rest, movement, and recovery can also shift gene behavior. Some switches can be softened, some can be reset, which means aging isn't simply written into DNA. It's shaped by how life interacts with biology, day after day. When scientists step back and look at aging as a whole, one pattern becomes clear. People who age more slowly aren't avoiding time. Their bodies are simply better at recovering from it. They tend to repair damage more efficiently. They return to balance faster after stress. Their systems don't stay in a constant state of strain. This doesn't mean their lives are easier. It means their biology adapts differently. Some of that difference comes from genetics, slight advantages in repair and protection systems. But much of it comes from how genes are regulated over many years. Chronic stress that never settles keeps aging-related pathways active. Lack of recovery slowly exhausts repair systems. While consistent rest, movement, and stability allow the body to maintain itself longer. Aging speed isn't about perfection. It's about patterns. Small signals, repeated daily, shape how fast the body wears or recovers. This is why two people with similar genes can age at very different rates. Because time doesn't act alone. Life sets the pace. Even with all these discoveries, aging remains one of biology's biggest puzzles. Scientists don't yet know exactly which gene changes matter most, or why the same lifestyle can affect different bodies in different ways. Some people respond quickly to change, others show little visible shift for years. Researchers are still learning how long epigenetic changes last and whether some can fully reverse over time. There are also limits to what we can measure. Biological age isn't a single number. It's a collection of systems, each aging at its own pace. And no study can yet predict how any one person will age. This uncertainty doesn't weaken the science. It reminds us that aging is not a switch to control, but a process to understand. One that remains flexible, responsive, and still unfolding. This understanding of aging isn't meant to make you chase youth. It's meant to change how you see your body. Aging isn't a failure, it's a response. Your body has been adjusting to stress, routines, and environments every single day. And while you can't control every factor, you can influence the signals your biology receives. Not through extremes, not through perfection, but through consistency. Rest that allows recovery, movement that supports repair, spaces that reduce constant stress. Small choices, repeated over time, shape how the body maintains itself. This isn't about adding years to life. It's about helping the body move through time with more balance. Aging doesn't have to feel like resistance. It can feel like adaptation. Common myths about aging often sound convincing, but don't hold up under science. One of the biggest is the belief that genes decide everything. If that were true, identical twins would age the same way, yet they don't. Another myth suggests aging only moves in one direction, as if once decline begins, nothing can change. When in reality, many biological systems remain responsive well into later life. There is also the idea that it's already too late, that if habits weren't perfect earlier, the body can no longer adapt. But biology doesn't operate on deadlines. It responds to what is happening now. And finally, aging slower is often misunderstood as avoiding age altogether, when aging itself is not the problem, imbalance is. Science isn't promising youth forever, but it is showing how resilience can be supported at any stage. Growing older is often framed as loss. Less energy, less strength, less time. But biology tells a more nuanced story. Aging is not simply the body failing. It is the body responding to everything it has lived through. Every adaptation was once protection. Every adjustment meant to help you continue. Some changes no longer serve you, while others still do, and that doesn't mean the story is over. Even later in life, the body continues to listen, to rest, to rhythm, to safety. Growing older isn't about fighting time, it's about understanding how the body moves with it. And once you see aging this way, it stops feeling like something to fear and becomes something to work with. Now take a moment and think about your own life. What signals is your body carrying right now, and which habits or experiences might be shaping your biological age? Or if you could adjust just one small thing today, one habit, one routine, one pause, what would it be? I'd love to hear your thoughts. Share them in the comments. Your reflections might help someone else see their own patterns in a new light. Because this isn't just science on a screen, it's about understanding our bodies, our choices, and the life we pass forward. Even one small insight can ripple in ways we don't yet fully understand.